In Venn diagrams, part 2, we're going to explore more about how we label regions of Venn diagrams and how we identify what is in various regions. So let's begin here. We have a Venn diagram with elements shown, and what we're going to begin with is just listing the elements in every region given on the left. So starting with number 1, list the elements in region B or in subset B. So what we need to realize is that subset B is this entire circle. It's represented by everything in there. And so if we're going to list the elements for set B, what we need to do is list every one of the elements within set B, that blue circle. So that would be B, K, D, J, N, E. And again, it doesn't matter the order in which we list them. All right, now if we want to list the elements in A intersect C, A intersect C, now we're looking at where does set A, represented by this circle here, which I'll trace in red, overlap set C, which is the one I'm going to trace here in yellow. So where is the region of overlap? That region of overlap is where the red and the yellow cross each other, or this region right in here. So if we're going to list the elements in the intersection of A and C, we will be listing D, I, M, and P. For the next one, B union C, set B is the one circled here in blue. Set C is this one circled in yellow. And remember, a union says put all of those things together. So for B union C, what we want is every element in one circle, the other, or both. So that does include the D and E here in the middle. So this is going to be quite the set when we start listing everything. We would have the J and the N, B, K, D, E, I, M, P, A, F, and L. So again, everything that appears in this entire region. Okay, next up we have A complement. A complement is everything outside or not in set A. When we look at all of the elements outside of set A, we are looking for all of the elements that are not inside this circle. We're going to look for everything outside, and notice that does include the elements C and G. So again, making a list of all of those elements outside of set A, we have C and G, as well as J, N, E, A, F, and L. Okay. All right, next, moving on to A intersect B complement. A intersect B complement. I'm going to use a little shading here, or highlighting. So A is this circle right here. That's representing subset A. So there is A. Then we want to do intersect B complement. So B complement is everything not in set B. So that's all of this out here. Okay, and where the intersection lies is where those two sets of shading overlap, because that's what an intersection is. It is the overlap. So where did those sets of shading overlap? The first set with the second set. Well, they overlap right here. So it is that last region that I just shaded that is A intersect B complement. And so that includes Q, H, O, I, M, and P. And then last but not least, I'm going to see if I can erase some of this shading here. It's not going to work out very well. I think I'm just going to make a bigger mess than what I've got. So I'm just going to leave it and then we'll go from there. Last but not least, we have A union B union C, and then the complement of all of that. So A union B union C means throw everything in A, B, and C together. Okay, throw everything in A, B, and C together. So that would include all of this. Everything inside those squiggly lines, fully inside, is A union B union C. And then when it says I want the complement of that, that means instead of what's inside, we want to move to what's outside. And so in this case, what's outside of that are just the elements C and G. Listing the elements, writing out each of the elements individually. All right, moving on to this version of the question. Now, this is the same Venn diagram that should look very familiar, except in this particular case, you might notice that I've asked a slightly different instruction. This says find the cardinality of each region. And as a reminder, the cardinality is the number of elements that are in that particular region. So in the last example where we listed all of the elements, here we're going to be counting the elements. And the way we know the difference is if you notice on all of these, we have this little N. That represents the cardinality. And I like that we use the letter N to represent the cardinality because I like to think of that N as saying the number of things in set, for number one, C. What is the number of elements or the number of objects, or in this case, the number of letters in set C? And so that's what we're going to be doing, is counting how many things are in each of these sets. So starting with number one, the number of elements in set C. So again, set C is this one right here. And so if we count the elements, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 different elements, and so the cardinality of set C is 8. For the next one, the number of things in A union C. A union C. So A union C means we want to combine everything in set A with everything in set C. So what we're going to do is count how many items fall in this combined set. And we're not going to double count the things that are in the intersection. Okay, we're going to count everything one time and one time only. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 will be the cardinality for A union C. For the cardinality of B intersect A, now what we're looking at is where B and A overlap. Where do sets B and A overlap? Well, B and A overlap in this region that I just traced. So if we count the number of elements in that set that I just traced, we discover there are 3 elements in that set. Next, we will move on to finding the cardinality, or the number of elements in the intersection of A and B and C. So what we're looking for is where do sets A, B, and C all overlap? And that's right here in this very center section. And we want to count the number of elements that fall in that section, and that is 1. There is one element in the intersection of A and B and C. For number 5, the cardinality of B intersect C complement. B intersect C complement. So let's start looking at set C, which is outlined here in blue. Okay, C complement is everything outside of this circle. So C complement is everything out here. And then we want to know where B intersects that. So where does set B, I'm going to highlight it here, where does set B overlap with everything outside of set C? Well, that region of overlap is this region right here, where they overlap with what's outside of C, but what is inside of B. So if we count those elements, we've got 1, 2, 3, 4. And so our cardinality is 4. And then last but not least, we want the cardinality of A intersect C complement. A intersect C complement. So for A intersect C, what we're looking for is where does set A overlap set C. And so the area of overlap is the one I am shading right here. That is the region of overlap. This region right here. That is A intersect C. But I want the complement of that. So what that means is I want to count every element outside of this region. I don't want what's inside. I want everything outside. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 as the cardinality of that set. So one of the things that you really need to pay attention to is the difference between, and then what is the cardinality of each region. Now, sometimes you're going to see the N and that will be a clue, but other times the difference is just going to fall in the instructions given. And so please pay attention to whether it's asking you to list all of the elements or find the cardinality.